Hi, welcome to the Calculus 2 lecture series. And we are started the unit number 1 is applications of integrations from the Calculus 2. You know, when we finished the Calculus 1, we ended up start to introduce what is the integrations, and we give some basic definitions, and one of the rules for the integrations we introduce at the end of Calculus 1 is the substitution rules, right? So that we know what is the basic integration about. So as starting the Calculus 2, in the unit number 1, we're going to take a look at what are the general applications of integration. And so our lecture number 1, we're going to take a look at how do we find the areas between the curves. And from the Calculus 1 at the end of Calculus 1, we know the integration. So when we talk about the definite integration, it's basically we are finding the area, you know, the under the curve and above the x-axis, and so we use the Riemann-Sum concept to get the areas, right? Okay, so let's start. You know, the lecture number 1. That's the first very basic application of the calculus, the integrations here. How do I find the area between the curves? Okay, let's go to our lecture notes here. Okay, so in this sections here, in this unit, so the section is 6.1, how do we find the area between the curves? So we have 3 key things we want to talk about in this section. So the first key concept is we're going to find the area, you know, we're going to find the area between, okay, so we're going to find the area between y is equal to the f of x and y is equal to the gx here, and the x is from the a to x is equal to from the b. Then we're also going to take a look at area between the x equal to the f of y and x equal to the g of the y, and then y is from the c and to y is equal to the d here. And then the last things here we're going to talk about is the area, okay, enclosed by 2 curves here. So for the first part, we're going to cover these 2. And then in the next video, we're going to cover how about for any area enclosed by the, you know, the 2 curves here. So let's take a look at what is the first one we're going to do. Find the area with respect to the variable x, like the first one, what that means here. So basically, the first one is telling you is like this here. Okay, so this is my x and y's, right? So we have y equal to the f of x. So I have a functions here. So let me give it different colors. So this will be my f of functions here, right? So let's say this is my f of x. And then we also have a function, it's g. So I say here, this is here, I don't want to have sharp corners here. So I said, this is my g f of x here. All right, so this is my g of x. And now I'm going to integrate between the boundaries here. This is A, this is B here. Okay, so that's what that means. The y equal to the f of x and g equal to the, the other function is y equal to the g of x. And what I'm looking for is the area, like this area, right? So this area between what? Between the two curve and bounded by these boundaries here. So basically, so we know for these functions, right? So all the y is going to be between these two functions, is gx and what? F of x. Now I know my x boundary is from the A to B here. So then the areas here, that's the area we try to find, remembers, right? So remember like when we in the end of the calculus 1, we say if I'm integrating f of x from the A to B, the dx. So let me erase this color here. All right, hope I can erase good. All right, so like in here, right? So we said the A of B, the f of x. So which area I'm looking for here? I'm looking for, it's these areas, right? So it's everything what? Is everything below the f of x and above the x-axis. So in order to find the pink area, I just, I drew before. So that's why I'm going to minus AB. This is the gx dx, right? So where is the gx dx? Gx dx is this areas, right? So it's the old area under the gx and above the x-axis. So then if you minus it, what is it? So this will be that you can combine it. It's because the boundary is the same. So you can have this is f of x minus g of x and the dx, right? So now what is the dx here? The dx is the area I just drew before. So right now this one is not going to show. You show the yellow. So if I get rid of the yellow here, so that's why, this is the area I'm going to find, right? So it's kind of like a pretty straightforward. And so this is the pink area. Let's try to do that. So you use the area of the f of x, the integration minus the integration of gx. So you basically, try to find the area below the f of x minus the area below the gx. That's what you're going to get the pink area. That's what the area we try to find. That's why we say this is, we call this respect to x, right? Why is respect to x? Is because I'm integrating to the x here, all right? So that's pretty clear, right? So this is the first type. Okay, so now let's take a look here. So the number ones here, they set up a definite integral for the area shaded below. Okay, so these areas, right? So this is the area shaded below here. Let me enlarge it a little bit. Okay, so this area, so the first things here, I know if I'm integrating, all right? So if I'm integrating from where? So this is the areas, right? So it's from x is from where to where? From the 0 to 4, right? So if I am integrating, let me try to use a color. So this one's here, right? So this will be what? The yellow ones here. So I'm integrating a minus 2x. So this is a minus 2x dx. That will be my yellow areas here. Let me kind of the color coding that, so it's like you will see what I mean. And then I want to find this shaded area. So I need to minus the area from 0 to 4, then this quadratic form give us. So what is this ones here? This is 2x minus 4 to the what? To the square dx, right? So what is this area going to looks like? This area going to be here, right? So it's a green area, so it's below this curve and above what x-axis, right? So let me highlight this is greens here. So now I know this one's here. Now I can just, because they have the same integration boundary, So I can just add, combine them. So this is a minus 2x minus 2, x minus 4 to the square, then the whole thing, right? So you can do here and the dx is here, right? So then this one here is a pretty straightforward integration. So you can just use what you learned from the, the previous chapter and the end of the calculus 1. So you hear this will just be ax minus x squared, right? And then use the substitution. I'm going to kind of skip here. I assume you know how to use the substitutions, right? So this will be the x minus 4 to the third. Then you substitute the 0 and the 4th here. Okay, so the answers here are already calculated that, so it will be 16 over 3 here. So it's pretty straightforward. I think intuitively, it's kind of easy to recognize, right? Okay, so now let's take a look at the second problem here. The second problem here is set up a definite integrals for the area of the region bounded by these curves here. Okay, so now let's kind of try to graph it first. Okay, so let's try to graph y equal to the x3. So this is a cube function. So when x equal to 0 is 0. When x equal to 1, this is 1. -1, this is -1. Right? So when the 2 is kind of big here. So I hope I can do a good curve. So everyone know this is the cube functions, right? So this is y equal to the x cube. Okay, so now let's do the other one, y equal to the 3 minus x. 3 minus x, x equal to 0, y equal to what? Y equal to 3 is here. X equal to 1, what is y? X equal to 1, y equal to 2. Correct? Okay, so now I can, so this one is here, this is y equal to 3 minus x. And now I am what? Then here, the next things here is say x is from 0 to 1, right? So x is from 0 to 1. So this is my boundaries. This is 1 and 0. So which area I am looking for here? Let's try to highlight that. So which area I'm trying to looking for? I'm looking for, let me see here. Okay, let's get a good color here. Okay, so this is the area I'm looking for, right? Okay, so the first things here, so we say, okay, if this is the area I'm looking for, so that means I can take the integration from 0 to 1 to this red function y equal to y minus 3x here, right? So this is y minus 3x. So this one will give you, let me use the same color, maybe that would be, so this one will give you the all the area under, right? Under this curve and above what? Above the x-axis here, right? Then I need to minus the 0, 1, this green function. This is x to the cube dx. I'm sorry, here I forgot the dx here. So what is this one covers here? This one covers is all these areas, right? It's below the curve and above the x-axis. So you minus it, it will give you what? Give you this yellow area. So now the same things here. So this is the area, the yellow area we try to find. And you can find the 0, 1. So this is y minus, oh, I'm sorry, this is not the 3 minus x here. Okay, so this is 3 minus x, g. Okay, so this is 3 minus x here, right? So it's 3 minus x. Then you can combine the minus x cube. Then the whole thing's what? Whole thing's dx here, right? And now this one's here, you can just use this very simple integration. So this will be 3x minus what? X squared over 2 minus x fourths over 4, correct? And then you put it as 0, 1 in there. And so if you substitute 0, 1, then what you will have, I got here is 9 over 4. So that's why I know this yellow area is 9 over 4 here. Okay, so that is what we talk about is the first part. How do I find the area between y equal to f of x and y equal to gx? Okay, so now let's take a look at what do we mean find the area respect to the variable y. Here, see here, okay. Okay, so now this is the situation. Let me kind of draw the picture for you, and then maybe you will get a better understanding here. So this is x and y. How about right now, my function is going like this. I have a first function is like here, all right? And then I have a second function. I have a second function is like here, okay? So if I have a function like that, and then it was bounded by, so y is equal to c to y equal to d. So basically, if I'm looking for the functions here, I'm looking for the area. This is the area. Then how do I do that? So I know for this type of the functions, right? So for this type of the function, and this one's here, we'll say the green one, instead of y equal to the f of x. So now we are kind of switched, you know, the x-axis. We say this one's here is what? X is equal to what? Gy. Then this one's here is x equal to what? F of y, right? So now x is a function of y, and because of x here, so we know the f of y is always greater than or equal to gy here, right? So now let's take a look. How do we write this one? So that means the x right now is between these two functions, gy and the f of y, and what is the y boundaries here is from C to D. So now instead of integrating to the x here, so now I'm integrating to the y's here, right? So okay, so now this area will be what? Then let me color coding that. So this is yellow areas, right? So it will be the same thing. Instead of you integrate, so I will say, okay, I'm integrating respect to the x. So that means I'm integrating this directions, right? For the x here. So the first one is here, right? So if I'm going to integrating f of y dy, so from C to D, so what is the area I am integrating here? Let me get rid of this yellow ones here. So what is the area I'm integrating for the, you know, let me try to use the colors here. For the f of y here, I'm integrating the same idea, just I'm switch the axis, right? So it's everything below the curve and to the right-hand side of the y-axis, right? So this one is color coding, is the f of y here. Okay, so now I minus the CD. Then if I have gy dy, gy is this green, right? So what is this area I'm integrating? I'm integrating is here, right? Everything to the left of this gy functions here. right? So let me color coding this one, see here. So if you use this one minus this one, so what is you end up to be? This yellow regions, right? Okay, so now here it's the same thing because they have the same integration boundary. So you can just say CD f of y dy minus gy dy, right? So in here I can combine and so I said fy minus gy dy so here, right? So exactly the same concept as the previous one, and you just kind of flip the x-axis to the y-axis. Okay, so let's take a look here. So for these ones here, let's say just set up a definite integrals for this integration. So in here, okay, so let's first take a look to see, you said, okay, can I do, because of y equal to x minus 2, y equal to the 2/3 x minus 1. So you will say, hey, can I do if I code this one? So if I said this one, you say, hey, can I do like this? You said, hey, for this function, this line here, right? So this line, you can say, hey, can I say this is f of x and then this line, I will say this is a gx. Can I just use like the, you know, the in here, the f of x minus gx? Or if you take a look here, all the way in here, all right, after 2. Okay, so if you take a look at this area, see here, everything after 2, this light blue area. Yes, you can do that. It's f of x minus gx, correct? But for this small area, but for this pieces here, these little pieces here, is not, it was not bounded by the gx, it's bounded by the x-axis. So you cannot in general just write the f of x minus gx, correct? So you need to divide it into 2 regions if you want to do the integration by x here. Okay, so now I know, you know, the previous one might not be a good one. Then you take a look, you say, how about if, can I, okay, so now let's see, can I integrate it to the y? So if you start from here to here to here to here, then you say, oh yes, they are all bounded by 2 functions here. So these functions here, this is the pink ones here, right? So this is this one, and this one's here, y equal minus x is here, right? So then you can say here, you say, okay, so for this one, I can call this one is g what? Gy, and then this one I can call it is f of y. All right, correct? Okay, so now after that, then I can say, okay, f of y. So because the first function, the f of y, right? So y is equal to the x minus 2, right? Because I'm going to integrate to the y, so I need to change x to be a function of the y. So x equal to the y plus 2. Clear? Okay, so now, so this will be my first functions, right? Now, the second function here is y is equal to 2/3. So this is a 2/3 x minus 1. So that means you need to change x to be a function of y. So first I flip the constant, it's 3/2 y equal to x minus 1. So now I can say x equal to the 3/2 y plus 1. Clear? Right? So that's why in here I have another function here, right? So now I know I can write the area will be equal to the function to the right is the bigger ones, right? So it's f of y. So from the 0 to 2, f of the y is this one here, right? So it's y plus 2 dy, okay? So what is the y plus 2 dy? You know, we are getting here, so here this is the, okay. So let's try to highlight, so which is this integration, try to get here, this integration is try to get this area, right? Everything to the left and to the right of the y-axis here. So let me highlight this one. And then minus 0 to the 2, and this one's here, right? So 0 to the 2 is 3 over 2y plus 1, and what? dy here. All right, so what is this one? We are trying to get this one's here, right? So this one is this areas, right? The green ones here, correct? Right, so will be everything to the left of the functions, right? And to the right of the y-axis here. So let's try to highlight, this is my green area. So now I can kind of the combined, so this will be 0 to y plus 2 minus 3 half y plus 1 dy here. All right, so this is still pretty straightforward integration. So if you do that, I assume you still remember. So the integration will be 1 here. Okay, so now let's take a look at number 4 here. So the number 4 here, they say set a definite integral for the area bounded by the region. Okay, so now first things here, let's just try to draw what we have here. Okay, so x equal to the 4 minus y squared. I'm going to use green. So y x equal to 0, y equal to the negative 2 and the positive 2. And y equal to 0, what is x? X equal to 4. So it will be a quadratic, right? So, but this quadratic is go like this way. Oh, I hope I can do a good quadratic. All right, so this is the quadratic form. Of course, this is very smooth. It's not like what I did. Okay, okay. Now let's take a look at the next ones here. This is x equal to the y minus 2. So when x equal to 0, y equal to 2 is here. For y equal to 0, y equal to 0, x equal to the negative 2. Okay, so all right, so that's y, and then in here, so the bounded by, so in here, okay, so this is okay, so in here bounded by y equal to the 2 and the negative 1. Okay, y equal to the 2 will be these lines, right? Y equal to the 2 and the y equal to the negative 1. So it's this line. Okay, so now let's highlight the area where we're looking for here. Is this 3 curve and this, so it's here. Correct? Right, so this is the area, this yellow area is what I'm looking for. So in here, right, so you say, can I use the integrated by x, like f of x minus f of y? So in here, because this is the area, I really cannot do that, right? Because then, so like, let's try to write what is this one. This function is here is x equal to the y minus 2, right? And this functions here is x equal to the 4 minus y squared. So if you integrate by y, so if this is here, you integrate the y by y here, I like to draw to show you. So if I integrate by y, that means I'm integrating these directions, right, according to, right, so by y. So that means in here, so for you always start here, and you have an end in the next function, you know, and the functions here. So you always have an upper bound and the lower bound, the functions here. All right. Okay. So now let's start here. So let's see here. So the areas here, right? So it will be what? Okay. So the first things here. Okay. So my y is from the -1 to 2. Okay. So now let's take a look at the 4 minus y squared. 4 minus y squared. So this is x. This is a 4 minus y squared dy here. Okay, so 4 minus y squared dy. So this is the function 4 minus y squared dy from the -1 to 2. Okay, so which area you are integrating here? You are integrating what? You are integrating these areas, right? Let me get rid of the yellow, so maybe now you know what is the yellow looking for, right? So now let's see, the one we set up will match that yellow now. Okay, so 4 minus y squared, right? 4 minus y squared, it will be from here to here, this area. Right? So from -1 to 2, okay? And then here, the y minus 2 here. So in here, okay, so y minus 2 here. So these ones here, I'm going to minus, this is -1 to the 2. This is y minus 2 dy here. Okay, so y minus 2 here, the minus, right? Because in here, the y minus 2, and for this area, okay? So this area, so is what? This green area, it is because it is on the left-hand side of the what? It is on the left-hand side of the y-axis. So the whole this things here, that's why color here is negatives here, is this right, this green kind of the triangles here. So now basically it's kind of like, so these two and this one, the green plus the pink is what is the yellow we're looking for. So that's why the theory still applies. So this is -1 to 2. So this is 4 minus what? Y squared minus what? Y minus 2 dy here, right? Because this is on the left-hand side, so the -1 minus 2 is this green areas here. So now this will be just become to our typical easy what integrations sphere. And I already did that, and the answers here is 27/2. I hope this is easy integration. You should be able to duplicate that. Okay, so that's it for this video. Let's talk about these two things, right? So it depends on what curve, what area you have, right? So now you need to decide you want to integrate to x or you want to integrate to what? To y here, okay? So typical when the problem give you, they're not going to tell you you want to integrate by x or integrate by y. So you need to look at the graph and see, how I'm going to integrate in that. Okay, and then the next video we're going to talk about the last topic is how about if you give me any two curves, how about if I have the situation, it's not nice like this typical examples, right? So how about if I have some curve like this and some curve, some curve like that. So I want to find the areas here, areas here, right? So which function I'm using here? How do I do this type of the problem? All right, but as will be that we're going to talk about in our next video. All right, so nice to talk to you. You have a nice day. Okay, so let's go over the next one in our next video. Okay, talk to you soon. Okay, bye-bye.